Hi everyone, Mark here with My Engineering, and today I'm going to be doing an update on Flange, the in-house flange inspection software that we developed to do flatness inspections in the fields, in your shop, wherever you need, rapidly and accurately using 3D laser scanning technology. I'm going to be doing a walkthrough today, showing you the entire process, start to finish, where you import your data all the way to the final report. Let's jump in. So starting a new project in FlangeVision, the first thing that we notice when we open up a new project is there is a very simple layout. And this is very much by design. It has been the intent all the way through the development of this software is that it is going to be a very technician field friendly software that requires minimum amount of training in order to achieve the results that you want. So first thing that we need to do is import our data. I'm going to import an exchanger. This is very important for a little bit later on because we added some new functionality by popular request. We're just going to name our project Exchanger E1, let's call this. And once it imports, it's going to show us a preview of the data. And that's where we can start to set up the different surfaces that we want to measure. So the ceiling face on this one, I can actually scroll in a little bit, is recessed. It's not a raised face. It's a little bit recessed. And then you have a couple of pass-throughs on this one. So it's a little bit different than your standard flange where you have that raised face. The functionality in FlangeVision works exactly the same. So I'm going to add ceiling surface. And first thing it's going to do, as always, is on the bottom of the screen here, there's going to be a ribbon that basically walks us through the different steps that we need to take. First, it wants us to set the datum. And so a single click on the surface we want to measure. Because this is a very small surface, it is going to, in this case, select flood fill the whole thing. We can increase our sensitivity a little bit if we want. That's going to increase more and more triangles that it's going to use for its surface. Or we can hold shift and click on other portions that it's not quite landing on. I'm just going to add a little bit more and more all the way around until we get the entire surface more or less highlighted. Maybe a little bit more here at the top. So that's looking pretty darn good. I'm going to hit confirm. It'll take us to the next stage. And that's going to ask us to set the inner diameter. So you see this inner magenta ring that needs to land completely on the ceiling surface. So I'm going to scroll in a little bit here and you can tell that it's very much off the data itself. All we need to do is select 3 points somewhere on this ring that land where that inner surface or ID, if you will, for the flange should be. And so we selected the third location and it repositions that magenta ring where we want it. It looks like it's coming in a little bit too far. I'm going to add a little bit more data here. That's looking pretty good. So we are going to hit confirm. And you'll notice the OD ring is repositioned to be concentric with the ID ring, but it is too large. So on the bottom here in this ribbon again, set outer diameter. It's going to be a single click this time because it is concentric, so we don't have to define the circle. So I'm just going to put 1 point right there. And we'll look around, make sure it lands all pretty good. I think that's going to be great. So we have set our ID, now our OD. We're going to hit continue. And now it wants us to set our orientation. So that's going to be our 12 o'clock position. Like on this flange, it is right between these two bolt holes here. And so it makes this nice little arrow. If that's exactly where we want it, I'm going to hit confirm. And so that reorients, it didn't change very much, but it reorients that location as your 12 o'clock. So the whole model will shift a little bit. And then we can scroll in a little bit here. And you can see these data points, these little white boxes that are dropped on the flange surface now. So there's 32 clock points all the way around. So every 11.25 degrees. And there's an ID, middle diameter, and OD measurement point. So this will be coming into play on the next page. The next thing we want to do is add our bolting face. And it'll be the same thing. So it wants us to set the datum. Because I was using these magnetic little flange paddles, so they had the markers on them, it definitely broke up the surface. So it is, again, I'm going to have to hold the shift key just to keep adding all the different chunks until we get all the way around. And so this one's going to be a little bit more finicky. That's pretty darn close. And that's going to set an average for the bolting surface to be measured from. I'm going to hit confirm. It'll ask us if we want to analyze flatness, and we do not. We don't actually care about the flatness on the bolting face. We just want to measure where it is relative to the sealing surface. So I'll hit no. And that's all I'm going to do on this one. If I didn't scan it on this particular one, the backside of the bolting face, we could actually measure the overall flange thickness. So we can just add another selection here. In this particular scan, I did not actually scan that, but what I am going to show you is a little bit of added functionality. So that, as I mentioned before, now we can do exchangers, so we can measure pass-throughs. And so you'll see these three little dots on the sealing surface, which is a drop-down menu. So we click that and say add line. And what I'm going to do is I'm going to scroll in a little bit here, and I'm going to drop one end of the line right here. I'll scroll over to the other side, add the other side right here, and it'll add this nice little line right across that pass through on the sealing surface. And all these little white boxes are going to be our measurement points. Set line, confirm. So that one is set. Now I want to add another one for this other pass through. Again, we're going to zoom in, add 1 point there, add 1 point on the other side. Confirm. So when we have our two pass through lines, we can name those if we want. And that's it. So we've set up all of our measurement locations for this particular inspection, and I can hit confirm and export. Now this is going to take us to our next stage where we actually build the report itself. It'll give us a preview on some of the dimensioning that is going on at the measurements. So our sealing surface is 141 thou recessed below the bolting face. Here it'll have our pass-fail criteria. And so this is a customizable option that we can put in. So it is hard-coded right now for PCC hard gasket, which is a max tolerance of 6 thou. And on your pass partitions, you can have -10 thou and 0 high. We can customize that. So if we go into our settings and our pass-fail criteria, you can input your own custom criteria, or you can just pick the PCC soft gasket, which I'm going to select on this one. And you'll see the results here change. So where we had quite a bit of red numbers, so those were fails as the PCC criteria. Now there's a lot more passes because the soft gasket is a little bit more lenient. So there's a more generous tolerance. On the next section of the results here, you'll see the circumferential measurements. So there's a graphic on the left-hand side with 8 clock points, ID, middle diameter, and OD. And that'll give you an idea of what's going on visually. Everything on here is going to be a positive number because the plane that it's measuring from is offset to the lowest point. On the right-hand side here, you have the table that will actually outline a little bit more what's going on. So 32 clock points, as I mentioned in the previous page, every 11¼ degrees, and your inside diameter, middle, and outside diameters. And if there's any fails in that column, you'll see them in red. It'll say fail here at the top, which in this case, all three columns are a fail because this one is large and the PCC tolerances are pretty tight. Radial measurements. So this is measuring across the sealing surface, also known as runout often. And so here you see there's quite a bit more on the passes, but there's a few fails that are a little bit outside of tolerance. And so you have the graphic on the left-hand side with the 8 clock points and 32 clock points on the right-hand side in a table. If I go a little bit further here, we'll have a color map. This is just a good representation tool so you can kind of see what's going on with the whole overall shape of the flange. I can see it's a little bit high at the top and the bottom here. It's getting a little bit low on the side. So it's got a little bit of a taco shape or cowboy hat shape to it. But overall, it is actually looking pretty darn good. And then at the very bottom, you'll see on the pass-throughs. So this is measuring in the direction of the arrow, all your points measured relative to that sealing surface. On the right-hand side, you'll have where you can actually fill in your report information. And so these actually auto-populate. Some of them you can see are already generated. So the last entry will automatically carry forward onto the next report. It just saves a little bit of time. And then certain entries that you use often will also be able to pre-populate from a little bit of a drop-down. So we're just called this whole project Exchanger E1. Client is My Engineering in Edmonton. Supervisor is going to be Wes. You want to remember that name. He is the sales manager that you're going to talk to when you want to order this software. Then it has a spot to put in your job number, your equipment. So the last one that I used on my last report was the Scanology K-Scan X, which is the same one I used to scan this flange. So I'm going to select that and it'll pre-populate the scanner along with the equipment serial number. Then you have your flange ID. So let's call it E1 top, whatever this might have been actually called. Your PNID size was a 36, class 150, line number, say E1, and line material, let's call it carbon steel. Of course, there's going to be a QA section. So this is going to be your visual check to make sure that the surface was actually good. It wasn't heavily corroded. There's no big wrench or cut marks across it. So if it looked good, we're going to hit a check mark on all of them, and then a section, of course, for notes. And then we can hit download PDF, and that will actually export our report. Just a quick review now of the exported PDF report. So it'll appear very similar to what we had on the report building stage within the software. All the same information is going to be there. It is worth noting that you can have a customizable section where you actually have your company logo at the top. You'll have the first section where you have your different surfaces that you set to analyze. Our ceiling surface, did we analyze flatness? Yes. Did it pass QC? No, it's outside of tolerance. You'll have your height to the next surface, which is our bolting face, and we didn't do flatness on that one, so it's an NA. Your pass-fail criteria that you used, so we used PCC1 soft gasket criteria, and your visual checks on that flange. So for the 12, 3, 6, and 9 o'clock positions, was it a good surface? Yeah, it looked fine to us. But the overall result is a fail because it's outside of tolerances. Of course, you're going to have your flange details and the project information, the notes, and an area at the bottom for a signature because this is an official report. Next page, you'll have a 3D view. So your top, front, side, and an ISO profile of that particular flange. On the next page after that, you're going to have your results for the circumferential measurements. So 8 clock points on the graphic and then 32 clock points on a table. Anything that's outside of tolerances is going to be displayed in red. Same thing for the radial results or the runout results, measuring across the surface. So your 8 clock points and your 32 clock points below. You're going to have on the last page your ceiling surface, just the color map. So you have a visual representation of what was going on with that particular flange. That's a nice little tool. And of course, your pass-throughs. So we have pass 1 and pass 2, and the distance measuring across each one. And so that's the whole process, start to finish. Very simple to use, but very accurate and very quick. If you'd like to know more or get a live demonstration, you can always reach out to us, info@myeng.ca. Stay tuned for more updates in the future. Thank you for watching. We'll see you in the next video.